Good day, students. Today we are considering solve problems on simple harmonic motion, considering maximum potential energy. The first thing to do is to write down the parameters so that you can find it easy in looking for the right formula to use when solving the problem. Now, the first thing to do, read the question to know what to put down as parameters. Mass 0.6 kilogram, force constant K 30 Newton per meters, extension, calculate the extension, question mark, use it to represent that, assuming it holds, the mass is now pulled down. Second condition, that's a distance of 6 meters, let's make it A1, which is 6 meters. So the first amplitude, let's make it A1, which is, we don't know it, we are going to look for it. A2 equals 6 centimeters, which is 0. Divided by 100, 0.06 meters. We are looking for the period, that's T, to represent the period. The maximum potential energy, maximum, we don't know it. And kinetic energy, we're looking for kinetic energy. Kinetic energy in this case is not maximum. Now, when you have maximum potential energy, you equate it to total energy stored in the spring. But kinetic energy will not be equated to the total energy stored in the string because it's not at maximum. Now, the 3 centimeter is the x. These are the parameters to use in solving the problem. Mass is the mass of the object being hanged. This is the force constant. This is the extension in the spring when the mass is hanged, but we don't know it. We don't know the extension. We need to look for it. A1 is the amplitude when the mass is being hanged in the spring. A2 is the amplitude when the mass is being pulled. In the question, we were told that it is being pulled down. This is the amplitude. This is the period that we're looking for, period of oscillation. This is the maximum potential energy. Take note, when you're looking for maximum potential energy, you equate it to the total energy stored in the spring because of this maximum. Because this maximum takes place at extreme end of vibration, and the kinetic energy is not maximum. You use direct formula for kinetic energy, which is half mv squared. And take note, we don't know v, velocity in the question. We are going to equate velocity to w square root a squared minus l squared. Now let's analyze our diagram. The first diagram is this. This is the spring. The normal distance of the spring before the mass is being hanged. Is 3 centimeter, which is equal to 0.03 meters. Now, when the mass is hanged, there will be extension. The spring, 0.6 kilogram. The extension, we don't know it. E, the total is amplitude. That means that amplitude will be 0.03 meters plus E, plus the extension. For the second diagram, we have the normal length of the spring before it's being hanged is 3 centimeter. We convert it to 0.03 meters. But when the spring is being pulled, you have 6 centimeters, which is 0.06 meters. This is the mass, which is 0.6 kilogram. This is the analysis of the two diagrams. When you are looking for kinetic energy, you make use of this kinetic energy. Potential energy, you consider this potential energy because it has not yet been pulled. here. It has not yet been pulled, but here they have been pulled energy due to motion. Okay, now let's go into solving our problem. We don't know extension, but from Hooke's law, you have F equals mg equals to ke. You know that force is mg. Use g when you are dealing with acceleration due to gravity. When you are pulling an object, it's the acceleration due to gravity. You use mg and not ma. You equate it to the Hooke's law formula, F equals to ke. You can relate formulas together in physics. Okay, now ke equals mg. Divide both sides by k because we are looking for E, extension. Extension equals force mass 0.6 kilogram times acceleration due to gravity. We have it G equals 10 meter per second squared, and our pi equals 3.142. It's a constant, which is 10 divided by k, with our k 30 as 10 meter per second squared unit, Newton per meters. From here, when you multiply, shift once, cancel the 0. We want to limit the rate at which we use calculator. Now you have 6 times 1 divided by 30. 6 in 6, 1, 6 in 30, 5. 6 and 1 over 5, which is 5 goes in 1, possible 0 point, add the 0. 5 goes in 10, 2 meters. Now we can now see that our extension is 2. We now add it together, 0.03 plus 0.2. That's 0.03 plus 0.2. Make sure we are adding decimal in the same line. 3 to 0 point. That's the amplitude, 0.23 meters. That's for the extension, and for the amplitude, first amplitude A1, first amplitude. While the second one, we denote it to be A2. This is our second amplitude, A2. To differentiate the two. Move into period. Let's solve the problem, which is the third problem, which is period. Period is 2 pi square root of m over k. Now, don't make mistake of putting k at the numerator when you are dealing with angular speed. The angular speed is square root of k over m. The method you can use to know it your own way is that when you are using w facing up, m, you know the two legs of m, capital of letter m is facing down. Let it be at the denominator. When you are dealing with w equals square root of k over m. But when you are dealing with time, because it's not w that's at the front, know that automatically m is at the numerator. Now let's solve the problem. T equals 2 times pi is 3.142 times square root of our mass 0.6 divided by constants divided by 30. Now have 2 times 2, 4. Start multiplying from the back. 2 times 4, 8. 2 times 1, 2. 2 times 3, 6. Multiply by, when you are shifting, when you are dealing with division, when you are shifting, you are adding the 0. But when you are dealing with times, when you are shifting, you'll be cancelling the 0. When you are shifting to the right, you'll be cancelling the 0. But when you are shifting to the left, you'll be adding the 0. That's the method of solving a problem without calculator. Now you are shifting to the front, add 1 the 0. This one turn to 6, that's 6 over 300. 6 in 6, 1, 6 in 30, 5, 0, which is 6.284 times square root of 1 over 50 equals 6.284 times square root of 50 goes in 1, possibly 0 points, add the 0, 50 goes in 10, 0, 50 goes in 100, that's 2, equals 6.284 multiplied by square root of 0.02, you have 0.1414, which is equals to 0.889 seconds. The next question is potential energy. The maximum potential energy. I told you when you are solving for maximum potential energy or maximum kinetic energy, you are automatically equating it to total energy stored in the spring, which is half Ka squared. Now, let's see half Ka squared. Now, we are using A1 that we got, A1, which is 0 as our amplitude in this case, which is, what's our K? Half times K, 30 times 0.23 squared. 2 into 1, 2 into 30, 15. Enough maximum potential energy. Maximum potential energy equals 15 times 0.23 times 0.23. If that's a calculator, we'll get 0.7935. Don't forget the units, joules. Potential energy. Next question is kinetic energy. We are looking for kinetic energy. That's the next question. But take note, it's not a maximum kinetic energy. We don't need to equate it to total energy stored in the spring. What we need to do is use half mv squared. But we don't know velocity. What we need to do is to write the expression for velocity, which is w square root of a2 squared minus x squared, which is equals to minus x squared. This is what you are going to introduce into V. Now Ke equals half m in the bracket w square root of a2 squared minus x squared. Now square it because of these two. Now half m, when you open this bracket, it becomes w squared. These two will cancel the square roots. You now have a2 squared minus x squared. You don't have the angular speed. Let's look for our angular speed. Angular speed equals square root of k over m. So when the angular speed is the two legs is facing up, make sure the m that is down is at the denominator. Down equals k. What's our k? 30 over m 0.6, which is square root. Let's do some translation. When you shift once, you add 0. When you are doing division, when you are shifting, you be adding. But when it's multiplication, you be cancelling it. Now, cancelling the 0. Now, it now become 300 divided by 6. 61, 605. That is 0. That's 50. Square root of 50. You have 7.07. That's what you're going to use as angular speed. Now let's now have that one to be half times, what's our mass? Our mass is 0.6 times angular speed 7.707 squared. Our A2 0.06 squared minus 0.03 squared. Kinetic energy now is 2 here, 1, 2 here, 0.3 times. Let's multiply 7.07 by 7.07. 7 times 7, 49, 9, carry 4. 7 times 0, 0 plus 1, 4 plus 0. 7 times 7, 49. 0 times, that's 0, 0, 0. Hey, multiply 0 times 7, 0, 0, 0, 0 times 7, 7. That's 0 times 7, 0. 7 times 7, 49, put 9. 7 times 0, 0 plus 4. 7 times 7, 49. When you add it together, you have 9, 4, 8, carry 1, 4 plus 4, 8 plus 1, 9. Add 2, 9, big 4, 9, 4. Now you are shifting method 1, 2, 3, 4. How many figure after this? 1, 2, 3, 4. Shift 1, 2, 3, 4. That's 49. 49.9849. Multiply by 0.06. When you multiply it twice, like the way you did it here, you have 0.0036 minus 0.03 squared, 0.0009. Kinetic energy now, because when you multiply them, you have 0.041 joules. That's the kinetic energy. This is the end of our class. Please subscribe to my channel. Have a nice day.